It's a continual, like, suspense. Continual suspense is what we're going for. Oh. Excellent connection. There's a button to press end stream. That's promising. I feel like, oh, that's a good sign. Yeah, now we're live. There we go. All right.
Hey, welcome to the stream, everyone.
Hello.
This is our first live stream, so if we have a few little teething problems, I'm sure you'll be patient with us.
Yeah, we're just playing guitar for the last 5 minutes so that we would, because you never know with a live stream if it's live and like when you actually try to get it live or 5 minutes later. But here we are.
Yeah, here we are. So the motivation for this live stream was that last year I did a video which was the science of 2018, and it was a lot of work, and I just felt like it would suit a lot better to a live stream where it could be interactive. We take a look at all of the science stories of the last year, and the way this is going to work is we've gone and taken there's this really good page on Wikipedia which is called the Science of 2019. We've gone through that and we've extracted all of the best science content for lots of different categories. So I've got a piece of paper here.
Yeah.
These are the categories you can choose from. So we're going to ask you to vote on what you want first, and then we'll take it in turns. We've each got we've done the research, split the research between ourselves, and so we'll take over and explain exactly like all of our favorite science stories of the year. And for me, I think there's a lot of negative news that goes around. I don't know if you've noticed that, but sometimes when you go on news or social media, it tends to be a bit of a bummer.
Yeah.
You're like, oh man, the world is a bit bad. But actually...
And even as someone that follows science news, like, there's so many amazing science discoveries and like science findings that I never even heard about that are like, wow, like people are doing amazing things. That's pretty uplifting. So yeah, Dom's idea is to share those findings with the world. So here we are.
Yeah, because it's an antidote, I think, to normal news, is looking at the advances people are making in science are really, I found, at least when I was doing this research, really optimistic and uplifting, and just amazing to see that we actually are making a lot of progress as the human race. So it's kind of like an antidote to all of that news. So yeah, I'm stoked.
I'm not surprised, but if you're looking at the comments at all, everyone wants physics or space.
Okay, physics or
this
space.
Is obviously on Dom's channel. So.
Okay, yeah, so why don't we start the voting? I'm going... Wait, could you hold...
I will hold this. So here, let's go through all the categories.
Yeah, so we have human evolution or evolution, space, artificial intelligence, genetics, climate change, technology. Can I do this? Oh, yeah, I can. Whoa. Medicine, and my favorite subject, physics. Oh, I tell you what we should do. While you vote, everyone's voting physics, genetics, physics or space. Shout out to me, please. Math, physics, physics or space. I think physics seems to be. Yeah, physics.
I'm seeing a lot of physics, which
Let's
is
start
cool.
off. I think what we should do. So we'll do physics. I just thought we'd introduce ourselves because we haven't actually done that yet. So presumably a lot of people know who we are, but if you're new, I'm Dominic Wallerman. I do this channel, Domain of Science. My background is in physics mostly, so physics is my subject, plus a bit of computer science, plus quite a lot of quantum computing, plus a bit of machine learning.
My name is Curtis Bowdy, and I run the YouTube channel Curtis Bowdy. I do over-the-top science experiments. I do a lot of videos about the environment because it's something I care a lot about, and it's what I did my Master's of Science in, and I did a degree in biology before that. So we're going to have like physics over on this side and like biology on this side, roughly speaking. That's
Sounds
the plan.
great. Okay,
Excited to be here.
Let's get cracking. Okay.
So we're gonna do physics.
Physics. Could you do the honors and cross off the physics while I load it?
Yeah, I'll do it right on the screen if I can. Okay. Here we go. I'll be proud of myself if I don't get marker on my arm during this, but we'll see.
Okay. Okay, so
Oh, and we should say this is going to be a marathon. There are a
oh
lot
yeah,
of things to cover. We tried
we'll
to
try
read
and
as much
keep
as
it.
possible. We tried to suss out what is happening in each of these, but we may get things wrong, and we apologize. Just stay with us, please.
Yes, that's a very good disclaimer. Obviously, we are coming to a lot of these subjects from like outsiders, trying to glean the information from the news reports, and so we've got a Google Doc where we've actually done all of our research. I think we'll share that at the end of the stream, so that in the future you can go and have a look at all the original articles of this, which I really recommend doing. But let's crack into it, and I'll try not to take too long. So let's see. So first article is Scientists Unveil the First Image of Quantum Entanglement. And so I don't know how much to say about this, but quantum entanglement is a feature of quantum mechanics which gives quantum mechanics some of its strange behaviors. And it's of interest because it's used in quantum technologies like quantum computing, and also it's the fundamental nature of how the universe works, so it's like a good thing to work out. And in this paper, what they managed to do was
capturing an image of quantum entanglement.
Yes.
Is that one of those like you can't, if you look at it directly, you're like messing with it things?
Yeah, exactly. So the thing in quantum mechanics is if you set up a quantum state, so a quantum entanglement is you have two separate particles, you bring them together, their properties overlap, so now those two separate entities become one entity. You need to describe them all in terms of quantum mechanics, you need to describe them all as one thing. So in entanglement, what that means is you can then take those two things far away from each other, even millions of miles away, or kilometers, we are in Canada. Right. And if you measure one of those, you immediately know the state of the other one. And that's so cool. It's a thing that freaked out Einstein because it's instantaneous action at a distance. He said it was spooky action at a distance. And so this is one of those things, as soon as you measure it, it actually collapses. So it's cool that they've managed to do this. Okay, should we go to the next one?
Yeah. So, all right, it's working. This is good.
Cool. So fusion energy is obviously a cool. If we can solve fusion energy, it will actually solve the energy crisis.
What is fusion energy, Dom?
Okay. Oh yeah, that's a good idea.
Brief.
Yeah, thanks. So fusion power comes from. So you've got a power station. It uses a fusion reaction, which is a nuclear reaction. Is what the sun does. Hydrogen, helium, smash it together. You make a heavier thing, lithium or something, and then energy comes out, and you can use that as energy to boil water. Every power station, you just boil water,
and it spins something.
Which it seems like maybe we could come up with a better technology to do that, but no, it's still like steam power, basically. That's what we're doing.
Very much.
So the trouble with fusion power and fusion reactors is that in the sun, the reason that the sun can keep fusion power going is because you got the pressure of the entire mass of the sun pushing it in and kind of containing the reaction. So the sun is like a continual hydrogen bomb, so like a nuclear bomb continually exploding. The reason it doesn't just explode out is there's so much stuff that it squeezes it in. You're trying to maintain that stably within a nuclear reactor, and that's really, really hard because these things are at such high energies. You don't have the pressure of the sun to contain it, and so maintaining the fusion reaction you need to do with very precise magnetic fields, and that's hard to do. And so in this advance, they've managed to actually stabilize that nuclear reaction using I think it was some kind of electromagnetic wave. Hold on.
Yeah, using radio waves.
Radio waves, right, that's it. Small changes of the temperature of the plasma to control it more.
They're basically creating a sun. Like, It's very
Yes.
similar, right? It's like the same physics.
It's exactly the same physics. Yeah,
That's mind-blowing.
it's the reaction that's powering the sun. Which, if we can harness it on Earth, it would be completely transformative.
Fingers crossed.
Fingers
I mean, this has
crossed.
been like since the 70s they've been trying to do nuclear fusion.
Yeah, I don't know when it started, but yeah, certainly 70s or even earlier.
But we're finally getting to the point where it's like it's really close now.
Yeah. So notable things that happened recently. I think it was about 4 years ago they had the first reaction where they got more energy out than they put in. And so that was a landmark which didn't get much coverage, but that was one of those points where you're like, okay, now we've done the experiment where we can actually get more energy out than we put in, which is, yeah, a landmark. Anyway, I'll move on. So that's a cool thing. Fusion power, a little bit closer. Generates. Okay, so this is generating power from a nuclear, basically a radioactive element called
Americium.
Americium. Okay.
I've been memorizing all of the elements. It's been fun.
Thanks. I would have called it Americium, but
I think it's that.
I'm sure you're right.
Guess what country it's named after? Okay, sorry.
Mercium.
Yeah.
You could just call it Mercium. So this is from nuclear fusion powers, which is the opposite to nuclear fission power, which is the opposite to nuclear fusion, where you take big atoms like uranium, you split them apart, or plutonium. In this case, you take plutonium, you split it apart, and you get americium. And what you can do is, because it's radioactive, it's continually giving out heat. Again, you can use that heat to generate electricity. And the first battery made on this material was made. And the hope from this is to create batteries that could power things like spacecraft for, I think they were saying, 400 years or something, really cool, from this one tiny battery, which is obviously useful for deep space missions where you're going far away from the sun and your solar panels don't work anymore. So that's cool. Another one, excitons pave the way to more efficient electronics. Okay, controlling excitons is a new kind of technology.
It sounds exciting. Sorry. I just don't know what an exciton is.
Okay.
Is it like a quark? It's smaller than a quark.
It is
something different.
Oh, no, it's bigger than a quark.
Okay.
Okay, I'll explain as much as I know. So an exciton is when you've got an atom. Atoms have got electrons around them, and you can excite those electrons into higher energy states by shining lasers on them. Then what happens is that creates a hole in the atom of a position. Oh, I should use my little space of window for my hands gestures. It creates a little hole in that atom where it's like a vacancy for an electron, and then the excited electron is now creating, well, the excited electron is paired with that hole, and so the exciton is the pair of those two things. So what you can do is you can actually use this as a kind of switch in electronics. So you can make excitons, and then if you can manipulate them, you can move them around and do things with them. It's kind of like electronics. And so the hope of this is that you can make a transistor where current transistors, you need to encode a 0 or a 1 in a chip. And currently what they do is that you need to have a little movement of current to flip it from a 0 or a 1. With this one, you could do it with like a laser pulse, which would be a lot lower power. And so that's the hope of this. So this is a cool advance. So
everything is better with lasers. Is what I'm learning.
Yeah, including CBAS.
That's cool. Oh, this is neat.
Okay, the SI units got redefined. So the International System of Units is how we define that's how we do science. The accuracy of these units is how we do science. So it's things like the kilogram, the meter. What are they?
Speed of light?
Let's see if I can.
Oh, that is based on the meter.
That's based. Well, the speed of light actually defines the meter.
Yeah,
so we've got the kilogram, we've got the meter, we've got
the second.
That's time. Yeah, time is the second. We've got candela, which is a measure of luminosity. We've got the mole, which is a measure of amount of substance. We
5, right?
have, I think there's 7.
Oh, temperature.
Yes, the Kelvin. Oh wait, they're on this picture. An ampere. That's the last one.
Electricity, right?
Electricity. And so these are.
We would have got it.
Yeah, we would have got it. This is the set of units that we've chosen to pin down, and all other units like energy or magnetic field or any of those other units that we use in science are all based on these. But for science to work, we need to know exactly how long a meter is or how heavy a kilogram is. And this redefinition is really important because we've managed to eliminate all physical. So we used to have a standard mass, which was a literal physical lump of metal that we were like, this is a kilogram.
Yeah, it was called the big kilogram.
Yeah,
in French.
And they had many copies of this kilogram, which they'd store around the world. But the trouble is, they kept drifting away from each other because they were absorbing carbon from the air.
Yeah, like their mass was drifting.
Yeah, their mass was drifting. And so then you had many different... And only by slight amounts, like atomic weights. But this is important because if you're trying to design incredibly accurate scientific experiments on these definitions of things like mass... if you've got different masses and they're drifting away from each other, that actually affects it's the baseline of the quality of the results that you can get.
It actually matters. Sorry. I'm just here for the puns.
Yeah. I'm glad you're doing it because normally that's what I'm doing too much.
We're in this. Yeah, like in old experiments too, we have the values. Like we had Eratosthenes' measure of the size of the Earth. But since he was using units that were like the size of a stadium for distance, like we don't know what his results actually were. Like these results matter. Like knowing the unit is what it all comes down to. So that's really cool.
Yeah.
So they defined the kilogram.
Yeah, which is very cool. And they no longer is it based on a physical mass. Now it's based on Planck's constant.
And that's the last unit, right?
Yeah, that's the last one. So they're all. I actually want to do a video on this, so subscribe to my channel because in the future, if you're interested in this, there'll be a video on it. So, cool. Okay, let's move on. IBM unveils its first commercial quantum computer. I've got some more quantum computing stuff in the technology section, so I'll probably wait until that. It looks cool. Scientists break the record for the highest temperature superconductor. Okay, so this happens just about every year, actually. We have some record-breaking result in superconducting. Well, maybe not every year, but there's very often stories. So the hope and dream of condensed matter physicists, who are the people who work on superconductors, is to make a room temperature superconductor, because it means that we could transmit electricity across the globe without losing any energy whatsoever. It would be 100% efficient.
And this one is at the temperature of negative 23 degrees Celsius, which is like, I would have thought it would be way colder than that.
Yeah,
that's cool. That's like, you could put that in Canada.
Yeah, you could just put that inside. If you made a computer out of that, you could just literally put it in a refrigerator and it would not lose any energy. Now the trouble is, and there's always a caveat, the only way you can get these very high temperature superconductors is by pressurizing them. So you physically squeeze the material within some diamonds, and when you squeeze it, you change the material properties of the electrons in that material. So that's how you get those high temperature superconductors. But the aim is to hopefully use these as information to work out whether there is a way that we can have a normal material at room temperature that exhibits superconductivity. And this will hopefully give us some more information on that. Okay, we found a new kind of light.
Yeah, I didn't know this. This is news to me. So.
Which, I have to admit, I don't fully understand it, but when light interacts with insulators, I think, or semiconductors, very close to the surface of those, you get a new kind of light, which is called this diagonal void waves, which sound cool. Sounds like something out of a Marvel movie.
The amazing thing about physics to me is that this was first, like this was suggested in the equations of James Clerk Maxwell in the mid 1800s, like 170 years ago, something like that. That's wild. And we're just discovering it now. That's cool.
So
I didn't know about this.
The implications of the electromagnetism discovered by him still haven't been fully investigated. So this is cool. I don't know what the applications of this are, but that would be cool to know. Maybe it's in the article. Okay, this is an example of a measurement type experiment problem. So physicists finally nailed the proton size, and hope dies. I'm not sure why hope dies. So this was a cool experiment. Basic question: how big is a proton? Right? You'd think we would know. Turns out, until recently, we didn't know. Wow. And the way you find there are two experiments you can do to find out the radius of a proton. So what you do is you take a hydrogen atom and you put it in a certain energy state where the electron actually exists for a certain amount of time within the proton, so inside the nucleus, because in quantum mechanics, electrons aren't in a specific place. They are a three-dimensional probability wave. So the probability of the electron can go inside the proton. And by looking at this thing called, I think, the Lamb shift, which is like a very fine energy spectra of the atom, you can do some physics and maths, and you can determine the radius of the proton. So you can do that, and then what you can do is you can take hydrogen, and instead of having an electron, change that out for a muon, which behaves just like an electron, got the same charge, but it's got a different mass, and so then it squeezes it. The probability cloud is a lot smaller, closer to the proton, and so it's got more probability of being inside the proton, and so you can get an more accurate measure of the size of the proton. So what they did is they did these two experiments, and they got different results for the size of the proton. So this is back in the day. Now, recently what they did was they repeated that measurement of the size of the proton using electrons, and they found that it actually agreed with the muon results. Huh. So before, when they disagreed, they thought, oh, there's some new physics here. But now that they agree, they're like, okay, those old experiments were actually wrong. So the old experiments for the size of a proton using an electron were incorrect. So this is what they found.
So we've refined it. Yeah,
so we've refined it. This is still science progress. It's not the most sort of like revolutionary thing like making fusion power work, but still,
that's cool though.
Understanding what the size of the proton is a very important thing.
I always just like to classify when people say like, oh, we were wrong. We don't mean like there is no proton. We mean like we're more precise now. That's what I'm saying.
Yeah, exactly.
That's cool. Yeah. That's super cool.
Okay, and that's it for physics for this year.
Physics is crossed off, everyone. Well, here. I'll find it eventually. Okay, so no more physics. Physics is done for 2019.
So
we need another vote.
We need another vote.
Which is up to you. So which category would like to see next? Human evolution, space, artificial intelligence, genetics,
musical interview,
climate change, technology, chemistry. Those are the options. We're going to go with whatever we see happening in the comments. We're going to get a cool guitar groove happening. I get one for space. I'm sorry it's not a secret vote. Climate change. All right. Power to that. Second for space, human. So space is the only one I've seen two of. Now genetics, medicines. 3 for space, 3 for genetics. Ooh, we're getting a lot of genetics.
I think genetics would be good.
Let's do. Oh, now we're getting lots of space. We'll do genetics.
Yeah, let's do genetics. Sorry, space people. We'll get to space.
We promise we'll get to space. We gotta go back. Whoa. Back. Oh, this is weird. There we go.
And
we were doing genetics. That's right.
Genetics.
Cool.
Yes.
Okay.
This is a cracker. Actually, you won't be disappointed.
Yeah, there's a lot of amazing and like kind of horrifying stuff happened all at the same time. I gotta open that. And go to this. There we go. I've subcategorized each of my categories, or I've subtitled them. Genetics is "Let's get weird?" question mark, because it's odd. So, okay. So for the first thing, there's a lot of. I mean, most of the genetics we do happens in plants, which is important because we need them to live. We eat plants, or we eat things that eat plants. So scientists recently figured out how to make photosynthesis more efficient. Photosynthesis, the thing that allows plants to eat sunlight and carbon dioxide in the air, it's actually really, really inefficient. It just evolved pretty randomly, and it actually throws out most of the energy that it gets. And you've probably seen it in high school, Rubisco, that really complicated chart. So anyway, they've basically, the long story short in this is that they designed a new plant that is 40%, yeah, that is 40% more productive in terms of its photosynthetic rate, which is super cool because that means that we're going to have advancements coming in agriculture as the population of the planet grows. So that's neat. Next up.
Very cool.
This is wild. This is something that happened this year that I didn't even know about, which is, I mean, I love genetics, so it's shocking that this slipped through. As the title says, a freaky 8-letter DNA could be the stuff of, well, the aliens title is weird, but scientists created, normally DNA is made with 4 bases, 4 letters, as you might say. And scientists recently created a genetic code that used 8 that they could put information into, which is really, really cool because, I mean, the more letters you have, basically, the more information you're able to encode in the same amount of stuff. So that's wild. Another cool thing about this is that it proved also, so in addition to being great for data storage, it also proved that there's other possibilities for what DNA could look like. So as this title suggests, maybe aliens have different DNA than we do, and I would think they would. Also, it's just really neat.
Yeah, just the idea that you could store information in DNA. So from a computer point of view, if you're going to make long-term storage of information, like we know all of our things, most people have had a hard drive fail on them, and computer memory just degrades over time. DNA has been maintaining itself through biological processes for billions of years. So if we want some kind of long-term storage, I feel like DNA is like a really good thing.
It's fantastic. And something that, I mean, we don't really know too much about where this will go just yet, but it's possible that since it doesn't interact with viruses and bacteria like normal DNA would, it might be even better for DNA storage, which is really, really cool.
Yeah, because nothing's evolved around
things
DNA.
Don't attack it like they do normal DNA.
And didn't they encode Wikipedia into it?
That's the next thing
up. Okay.
No, it's good. We're so I think that this was done with regular DNA. No, it wasn't. It was with the synthetic DNA. Scientists encoded all of Wikipedia into DNA, which is mind-blowing. The rate at which they can encode information is also super fast. If you think about, like, we're just figuring out how to do this, and it already is at, where is the information? Is at 4 megabits per second right into DNA. That's wild. That's like a phone call. You're calling, and it's the DNA is recording what you're saying. That's amazing.
What?
Yeah. So, and Wikipedia, for the record, is huge. It's 16 gigabytes, and I did the math. That's about 53,000 books worth of information, and you could fit that in a single cell, which you couldn't see, obviously. It's like, that's incredible. So
that's very cool.
It's really exciting.
It's like a glimpse. Physics is always a glimpse into the near future, like fusion power and stuff like that. I find genetic engineering is always, this kind of biological stuff is always sort of a glimpse into this crazy future where we've got biocomputers that are just weird, like cells growing out of our brain interfacing with our minds and creating super brain humans. Sorry, I'm probably going off on one a little bit.
That's a little bit sci-fi, but it might be possible at some day, and that's really neat. And at the very least, for storing information, like, this could be something that we have in the future. Like we store, instead of having to back up all our hard drives, we just have a little tumor and it's all in there. Who knows? I don't know. We'll see. It's exciting though. Search and replace editing. Okay, so this is like, you need to know a little bit about how genome editing works. So everyone has a genome. It's all your genes, all the information that makes you up. And scientists basically made this really big breakthrough in editing a genome without having to basically. So DNA is these two strands, the double helix, and scientists figured out how to search and find a piece of information in that code and replace it without breaking those two strands apart, which is normally how it's done, which is really exciting. It means that there's like an entirely new type of genetic information encoding that we might be able to do soon. You've heard of CRISPR-Cas9. It's like that, but hopefully even better. That's the idea.
Yeah, that was when I read this, I was like, whoa, something better than CRISPR.
Yeah.
Because CRISPR has been seen as this amazing technology, but as people have researched it, they found there's significant issues if things aren't edited correctly. You can have mistakes that happen far away from the place that you're actually doing editing. So it's kind of cool that there's another technology coming along, and this might not even be the end. You know, there's going to be more advances in these techniques, so that's very cool.
Yeah, and and in this, as if it's the right one, G8. No, it's further up. Okay. Is that? Oh yeah, and they call this prime editing, which I think is really, really kind of great as a title. I think that's it for genetics. No, there's more. There's more. I got this. Oh, I wasn't keeping up with this.
Oh yeah, Wikipedia.
Oh yeah, so this is Wikipedia. I just didn't move forward in the right way.
Mm-hmm.
So okay. Wikipedia, we've talked about that. Okay, so this is the ethical, cringy side of what's happening.
So we've moved from the cool
like
stuff,
cool genetics,
to the what are they doing?
Yeah.
Is this okay?
So we as in humanity, or our species, has started to do all sorts of cloning experiments, including the first cloned and gene edited monkeys, which is kind of wild. So the idea for this experiment is that we do a lot of research using monkeys because they're very similar to us, broadly speaking. And the scientists wanted to have a set of monkeys that were identical so that they could do very specific controlled experiments on them and have them all be the same. And they did that, and this is what they've done in China. The problem is that obviously this is a bit of an ethical mess because they're basically making cloned sick monkeys, and like I don't know if we're really ready to be messing with like DNA at that level. I mean, like the whole primate family is really intelligent. I feel weird when they're even in cages, but anyway.
Yeah, I mean, this whole area I've not had to do anything personally with.
Yeah.
So like I understand the arguments that in animal models for testing drugs, it's a necessary thing to test it in before you move on to humans. So in clinical trials of drugs, we wouldn't have the drugs that we have today that are saving lots of people's lives without animal models. The trouble is that you're totally right about using primates to do this. Is like they're very close to humans, which is why they're attractive to use in these experiments. But then, yeah, from a moral point of view,
normally when doing any sort of biology research that involves animals, there is a huge ethical, like a bunch of steps you need to go through to make sure that it's going to be okay. And there's actually like a board of ethics that you have to get approval from.
Yeah.
But in some countries, this is done a little bit differently. We're going to see another story that is similar, and then we're going to follow one story in particular through a bit of that thread. First, monkey/pig chimera, which is basically when you have two species combined into one genetically, was created in China. So this is another pretty wild story. It's basically what it says. They're mostly, as you can see in the image, it is mostly pig. They have, I think, less than 1% of their DNA is from a monkey. But this is like the first time, I think one of the first times in mammals where we've done like cross species, taking DNA from one mammal and putting it into another, which is pretty wild. Something that you never find in any sort of cloning or genetics study, which I always find shocking, is the amount of attempts that it takes in order to get one of these right. So it took.
I didn't even think about that.
Yeah, they grew only one human cell. Okay, wait, not that. So it took 4,000 embryos to get 2 of these chimeras. So it took like a lot of. This took a lot of pigs, and I don't really know if there is a good point as to why they did this. I'm not sure what the actual goal was. I know that long term we're hoping to get we're hoping to make improvements in how we get organ transplants and organ donors. It would be nice if we could. I mean, I'm vegan, but it would be nice if we could have organ donations from an animal that we could grow.
Oh, so
something.
the
I think
idea
that's
would
the idea.
Okay, the idea would be, say, grow a human kidney in a pig and then harvest it. Okay,
which is kind of weird. But anyway, this is like reached. There was a lot of criticism in the scientific community about this.
Okay,
but not as much as the following one, which has happened last year and then is continuing to be a bit of a mess this year. There was a research lab in China that created CRISPR human twins, so genetically modified humans, last year. And even the Chinese government was like, whoa, we did not give you approval for this, like what is going on? And then separate researchers this year figured out that they probably had their brains like accidentally enhanced. And like we're not really going to know what that means until these people grow up.
This creeps me out so bad.
The goal for this experiment was to modify humans to these two twins to not have HIV, because there's a gene that prevents you from getting HIV. And so they had that, but they also might have had their brains accidentally enhanced, which is like a sign that maybe we don't quite know enough about what we're doing to be able to do this stuff. Like, let's just slow down. This is the scientific consensus on all of this stuff is like, you did what? It's way too early to start doing this on humans. Yeah.
Because, I mean, it doesn't take much to understand the ethical problem with creating human beings who have had genetically edited genomes. Yeah. And
then next up, this story followed that same thread and it made really big news, but I think it's something that also happens in science that I wanted to address really quickly. There was another study that came out saying that not only did they probably have their brains edited, but they probably have shorter lifespans. And then we did more research about that research, and we retracted that paper. So just saying that whatever you see in the news as science news, it can take time to be verified or discredited. So that's why we're doing an end of year wrap up, because that paper was taken away. So they maybe don't have shorter lifespans, but
right.
We still probably shouldn't do it.
Yeah.
Anyway, it's in that Wikipedia article, and I'll make an edit to it.
Cool.
Okay. And then we get to pick a new category.
Ooh.
That's it for genetics. What do we got?
Okay, we have still. Would you like to do a musical interlude for us?
I can do that, yeah. I can do my best.
We have human evolution, space, artificial intelligence, climate change, technology, chemistry, and medicine. That's wonderful.
Got lots of space. I see space from here.
Oh, you see space? I think mine's updating slower than yours is. Oh, space! Everyone wants space.
I should have played David Bowie.
Space.
I feel like.
Oh yeah.
I feel like the crowd has made it clear.
Okay.
Let's go to space.
Let's go to space. All right.
You gonna cross that one off? I'll bring this up.
Great.
And I'll switch this.
Hello to everyone in the chat, by the way. If you've joined us since the beginning,
I saw
welcome.
In and Out made a donation. Thank you.
Oh,
it was a while ago, but I wanted to still say it out loud. Going to space. Here we go. This is cool.
This is all so cool. This is also quite a long one, so I'll see if I can rattle through it. But okay, first story, which you all saw. I did a video on this.
If you haven't seen that, go check that out.
Yeah. First image of a black hole. And technically, it's not actually of the black hole. It's of the emissions from the gas around the black hole. But essentially, it's of the black. I mean, the thing in the middle here is where the black hole lives. And the technology around this was really cool. So it was done using a bunch of radio telescopes. I think it was the let's just get up my informations here. So
the black hole is 54 million light years away.
Yeah,
wow.
54 million light years
That's
away.
Really far.
The Event Horizon Telescope project was the project that did it. It involves collecting the data from, so they're radio telescopes, so they see in the radio waves, which are very long wavelengths. And they used a collection of multiple telescopes all around the world and combined the information from all of those together to make an effective telescope the size of the Earth. So basically we turned the entire Earth into a radio telescope, and that allowed us to resolve things as small as this. And this is like way smaller than dimensions that the Hubble Space Telescope can see. Cool. So this is very, very cool. Black holes are interesting because well, for many reasons. They're the most extreme objects we have in the universe. At the center of them, they've got a gravitational singularity. They're so massive and dense that they rip a hole in space-time, and the laws of Einstein's theory of general relativity completely break down. So basically, they are a hole in our knowledge of physics. They're firmly in the chasm of ignorance. And the other reason why they're really, really interesting is because we have a big problem in physics, which is we don't know how to mash together our understanding of the large things, which is gravity, Einstein's theory of general relativity, with our understanding of the very smallest things, which is quantum mechanics.
I'm just here for jesters.
Because those two things don't interact very much. Atoms don't really experience gravity very strongly because they've got hardly any mass. And big things don't exhibit the properties of quantum mechanics like entanglement and superposition, those things I was talking about earlier. But you do get them both appearing in black holes, because black holes are so massive and they're curving space-time so much that now that is actually the interface between well, it's the one object that we know of where those two things meet. So at the surface of a black hole, the thing that Stephen Hawking got incredibly famous for, Hawking radiation, was he actually put together the laws of general relativity with the laws of quantum mechanics and saw what happened. And there are a few different models of black holes. We still don't know how they work. We don't know if they destroy information. Like a normal description of a black hole is that it destroys everything that goes into it. But the trouble is, in quantum mechanics, you can't destroy information. So they're a puzzle, and stuff like this will give us more information about how black holes work. And hopefully in the future, black holes might be the key to unlocking a grand general theory of physics where we'll understand everything.
I thought that this photo was just cool because it taught us about black holes. I didn't realize that. That's awesome.
Yeah, it's a very cool stuff. And the technology behind it is cutting edge and amazing too. Next story, fast radio bursts. So this is also in the realm of radio astronomy, looking from signals in outer space with very long wavelengths. And this is really interesting because we don't know what's creating these signals at all. And what we know is they're from very far away. They're from some astrophysical event which is incredibly high energy. We don't know what is causing that. And at the start of this year, we had seen some fast radio bursts, and we'd seen one which repeated, which was quite a shock, because normally high energy events in the depths of space only happen for a single event, like a supernova or a collision of neutron stars or a neutron star falling into a black hole, something like that. That only happens once. What's weird about these fast radio bursts is they happen over and over and over again, so they're repeating. By the end of this year, we've found 10. So now we know about 10 of these fast radio bursts, repeating fast radio bursts. Some repeat slow periods, some are quite quick. And I think they're not all... so it's not like a ticking of a clock. They happen with different times. So we're thinking maybe those other fast radio bursts that we've only seen one event of, maybe those are actually repeating. We just haven't looked at them for long enough. And what's cool is this is still a mystery. We don't know what is causing these.
Probably not aliens. I feel like every time we find something new in space, they're like, it's aliens. And then we're like, actually, it's this natural phenomenon. But
in the chat, tell me if you think it's aliens.
I mean, you're asking the internet. They're going to say, I'll be disappointed if they don't say aliens. Also,
okay.
Hi, everybody that's watching. A whole bunch of people are just joined in.
So, next story. What is this? I can't remember what this is. Let me have a look on my list. New study reveals the extent of underground water on Mars. Okay, this is Mars water. Okay, a few different cool results have occurred over the last year about Mars water. So, one, we know that there used to be... Oh no, I've got ink on my thumb. We know that there used to be groundwater on Mars, a series of reservoirs. So we've detected the signal, which is with these results that you're seeing on the screen now.
And we've seen like ancient signs of water. Like of lakes, there's like, right?
Yeah, this is the ancient. So they're dried up now. There's not water in them now, but we've got this signature that there used to be lots of reservoirs of water on Mars, and so that's true facts. There's an indication also separately from this that there could still be underground water reservoirs. How are we doing on the aliens?
It's lots of aliens.
Lots of aliens.
All caps. I like it.
So we've got an indication that maybe even nowadays there are liquid water under the surface on Mars. It's not shown to be proven to be correct, but we've detected some, I think, is it the New Horizon spacecraft?
I don't remember. And this is like very briny water, but water. Which would be cool. And this is important because if we went to Mars, well, two things, right? This is important because if we went to Mars, we could get water out of the soil, basically. And wherever we look for water on Earth, we find life. So potentially, maybe, aliens.
Could be aliens. Actual aliens.
But for real. Like it could actually,
you could
actually find microcellular aliens.
Yeah, it was the InSight lander, which landed on Mars, that discovered some magnetic incongruities. That's not evidence, but that's one explanation. So it's just interesting for the future that future space missions could actually target that to see if that's actually really true. Cool. Okay, Scott Kelly spent a year in orbit. His bodies are not quite the same. So this was the twins study by NASA, and they were looking at what changes happen when you send one twin into space and keep one of the twins on Earth and see what changes. So the changes that they found were that persistent changes were observed even after 6 months, including some genes expression levels, increased DNA damage from chromosomal inversions. I don't know what that is. Do you know what a chromosomal inversion is?
Yeah, I think it's when the chromosomes are like a tangled mess, and they can basically touch each other and have gene swap over.
Oh,
I'm pretty sure. It's been a while since I've read about that. But...
Increased numbers of short telomeres, which is how our cells age, I believe, and attenuated cognitive function. So going into space is actually like a bit of a rough time on your body.
Which I'm not surprised about. I mean, you ride a giant explosive off the planet into a like solar radiation, zero gravity. And then you're also like really you do all the experiments and work super hard. So it's no shock, but that's interesting. That's cool that they can actually like experiment with this with two twins.
Yeah.
I love that.
And the experiments are obviously really useful for long-term space exploration. If we want to go to Mars, if we want to settle on Mars, all of this stuff is really good to know. Most of the news is not good, though. So they've done other studies on people's biology. So there was... they also found this year that dormant viruses in the body might get activated in space. So you've got viruses in your body that are not doing anything, but you're in space and now they start being active.
I wonder what's causing that. Like if it's because your body's stressed out.
Yeah, I don't know.
Got to send more twins to space.
Yeah.
I'm into it.
Also, astronauts on the International Space Station are more prone to blood clots, which is not a good thing. Astronauts experience serious blood flow stasis. So basically blood stasis, where your blood is not moving around your body. I guess we're used to the gravity pushing blood downwards and then we pump it back up again. So blood being in stasis is where it's just not moving through the blood vessels, which means that it's more prone to clotting.
Space is dangerous.
Space is dangerous. Yeah. So for long distance missions, I think we're just going to have some kind of microgravity or some like spinning thing, kind of like in 2001. Okay.
Cool.
Next mission. Unusual supernova, rare wind at the collapse of a star.
Whoa.
Oh yes. So this is an event which I reported on last year in my wrap-up of science of the year, which is very amusingly named 2018 COW and COW.
Always physicists, they get the best names.
And it was a very powerful astronomical explosion, 10 to 100 times brighter than a normal supernova. So it was an insanely bright supernova, which we didn't quite know what was causing this. Again, it was like so powerful that we didn't know what it was. We now think that it was, it could have been a white dwarf star being pulled apart by a black hole. I'm
so glad we're a long way away.
Yes. Okay.
That's
Next
cool.
one. A superluminous object. I think this might be the same one, actually.
Like a star, yeah. That seems like the same.
Oh yeah, this was the sad news of the year. The Opportunity rover finally gave up the ghost after 15 years.
So I mean, sad, but not. Like I feel like that's like a cause for celebration. Not that it died, but that it was supposed to last like 9 months or something.
Yeah,
right?
it was,
like it was like the really short expected life expectancies.
Yeah, it lasted for 15 years, which is
really
amazing.
Cool.
So that's very cool.
Hopefully, Curiosity will keep going for as long. We can only hope.
Just to bring up the aliens topic again, this is positive results showing how life on Earth is how resilient life on Earth is to being exposed to empty space. So in this study, they put on the International Space Station, they put extremophiles, archaeobacteria, cyanobacteria, algae, black fungi, and all sorts of other things out into space. And they discovered that all of these different microorganisms showed some level of survival. And the best survival was amongst archaeobacteria, fungi, and biofilms. So
in space.
Being the vacuum, exposed to the vacuum of space, life can exist.
Which is super cool and like interesting because like rocks transfer between planets and asteroids and all the time. Like we regularly get asteroids that have been parts of Mars that have been broken off of Mars and flown into space and landed here. Like that happens. So maybe life could hitch a ride, which is pretty neat that we have like evidence that that's possible.
Yeah, it
has to go through the atmosphere, which is super hot, but some of those archaea are known to do that, so that's really neat.
It's just very cool that all of this happened this year. I have to keep reminding myself of that. This is just this year. Okay, we found more moons of Saturn. So now Saturn has got more moons than Jupiter.
I didn't know that.
82 moons. Jupiter has got 79. That's cool. We found buckyballs in interstellar space. So buckyballs are this configuration of carbon atoms, into a molecule that resembles kind of like a soccer ball. And we found that those form in interstellar space, which is cool. Yeah, we did a survey of the mass of our Milky Way galaxy. It's twice as heavy as we used to think. Whoa. Or twice as massive, I should say. And 90% of our galaxy is made of dark matter. So
that's so much.
So I saw some people in the chat earlier asking what dark matter is. So I'll just explain dark matter quickly, at least what we know of it. So
this will take me days. I'm glad you're
When we look into deep space and we see galaxies, they form these spirals and these clusters, and you can watch them spinning at a certain rate. Now, spinning things tend to fly apart because they're spinning, right? But galaxies maintain their structure, and when we look at them, all of the stars that are shining don't create enough mass to actually hold the galaxies together. So there has to be something else contributing to the mass of those galaxies. That was the first indication we had that there was something else that we couldn't account for. So there's some form of mass that we couldn't account for. Now, we haven't found what the source of that mass is yet. The most likely candidate that we have, or the one that seems the most popular, are these things called weakly interactive massive particles, which is a new kind of particle, the kind of things that they look at in CERN, those big particle colliders. They really, really would love to increase the energy of those particle colliders to see if they can create some dark matter particles. The trouble with dark matter is it doesn't interact with our normal matter through electromagnetism, so through the force of electromagnetism. So that's how we see things. So how we see anything is because it's interacting with light. So they only interact through gravity, and gravity is such a weak force, it means that it's incredibly hard to actually investigate that stuff. Anyway, so this is dark matter, and that's why that's so cool.
And there's more of it than we thought. That's cool.
Crash lunar lander spilled tardigrades on the moon. Oh yeah, so this was an unfortunate failed lunar mission, which crashed on the moon. I think the Bereshit mission. So it was trying to be a lunar lander, and but it crashed, and so it released tardigrades on the moon,
which were supposed to be there for an experiment.
Yeah, and also released a laser etched copy of Wikipedia.
Well, that's cool.
So at least they got something to read.
What's important for those of you that don't know about tardigrades or water bears is that we think that they can probably survive like environments as extreme as the moon's environment. So they might be living on the moon.
Well, only in a sort of desiccated hibernation state. So they're not dead, but they're not alive, and they're not doing anything. So it's not like...
I mean, they're not... They are alive.
Well, sorry.
They're like a seed.
Yeah. It's like a seed.
Not a tree.
Yeah, perfect analogy. But they're not going to move around and start multiplying and...
Yeah.
But anyway, interesting. You have to keep an eye on them. And that's it. That's it for space.
Next section.
Next section.
Play the guitar, and we'll.
Oh yeah, sure.
There's a time delay, which is why Dom is going to give us music while you vote on the next category.
Oh, and maybe we should reintroduce ourselves.
Yeah,
to people who have joined.
Anyone that's just joining in, I'm Curtis Bowdy. I run the YouTube channel Curtis Bowdy, where I do science and environment experiments and projects. And this is
Dominic Wallerman. I do this channel, Domain of Science, and I'm a human.
Vote on what category you would like to see next. We've covered physics, genetics, and space. There is still human evolution, artificial intelligence, climate change, technology, chemistry, and medicine.
I'm definitely not an alien.
Well, I mean, no, he's not. He's not. I can verify. I mean, I'm seeing a lot of climate change. Which is like my daily life, and chemistry.
We're all seeing a lot of climate change.
We are all seeing a lot
that seems like a good topic.
Okay, let's do that. And also chemistry, but maybe that next. Okay. You want to cross this
Yes,
off?
I'll cross it off.
And I will get out.
How are we doing for time? Okay, it's 1
It's
hour.
1 hour
We're 1
in.
hour in.
Which is
We've
good. I think
done-
we're about halfway.
Yeah. No,
not
slightly
quite
less,
halfway.
but that's okay.
It's a marathon. We've covered some of our favorite topics, so maybe we'll go faster through the other ones. I don't know. We'll see. Okay, I got to bring up climate change. This was a big year for climate change in a lot of ways. Let's bring up the thing so you guys can see what I'm actually talking about. Nope, this one. Okay, so this is a big year for climate change, both for the planet and for the people on it. I'm going to start with the category. Oh yeah, the subtitle for my category of climate change is the Anthropocene. I can't say it. Anthropocene. Thank you. Which is like scientists agree we're currently in a mass extinction event that's caused by humans. It's going to be a dark category, mostly, I gotta admit.
This is the way I see this. Obviously, the motivation for this live stream is to show all the positive results from science. This obviously is going to come across as very negative because just what the science is telling us we are screwing up the climate. But I also see a positive side of this, is that this is really important information to know, and the better we can model the climate and understand all of the processes, the more we have the tools and the weapons to fight the information war and the political war.
Yeah, and there's also some good points to know. Like some good things happened in the science of climate change, which I'll talk about. First thing, at the very start of the year, scientists announced that 2018 was the 4th warmest year on record in recorded history. For the entire planet, which is no huge surprise. If you look at the 10 warmest years, I think almost all of them are in the last 15 years. And 2019, though it's not quite done yet, is shaping up to be, I think, the 6th warmest year ever. It's been hot. The planet is getting warmer. I'm going to go quickly through I'm going to do kind of a lightning round of some of these. So climate change is being caused by increased levels of carbon dioxide in the atmosphere, and in Hawaii, which is far away from everything else, so they can take a base level, where is the carbon dioxide at in our air. In Hawaii this year it crossed 415 parts per million, and that's a big threshold. It used to be around 360 originally, right? And we've caused it to go that much higher, which is the highest level it's been in the last 2.5 million years. And at that time, 2.5 million years ago, sea levels were 20 meters higher than they are now, and the temperature of the planet was 3 degrees warmer Celsius. So, I mean, that's like where we're headed. That's the direction things are going. Good news in the climate crisis is that scientists are finally starting to get a little bit more political and actually stand together more on the issue. So they recently signed 11,000 scientists set out a political global warning that climate change is happening. And and the second study from that is that someone went through all of the research for the first, I think, 7 months. For the first 7 months of 19, looked at every peer-reviewed climate paper, and all of them agree that climate change is happening. 100%. And that's 11,600 papers. So it's at the very least now we've kind of weaned out all of the bad science, and scientists can all back the fact that climate change is happening and it's because of us. And that's good news because it leaves no room for climate denial. So that's good. If you get into a discussion with a climate denier, you can show them this article. Cool. That's the good news. The bad news is that it's melting. The world is melting. So I'm going to go through these kind of quickly because they are repetitive, but I think it's important to kind of give you a bit of the scope. Greenland ice is melting 4 times faster than it was in 2003. That's a big deal. Another example of ice melting, the Arctic ice sheet is melting at a rapid rate, 11 billion tons in one day, which is the equivalent of 4.4 million Olympic swimming pools of ice melting into water in a single day. that never used to happen. That's like unfathomable, which is pretty wild. Yeah, if it continues to rise and melt this, or if the Antarctic ice sheet continues to melt this way, then we'll expect to see a multi-meter sea level rise, which is pretty scary.
Yeah, we definitely want to avoid that.
Yeah. Oh, and then this is, so that was Arctic. This is Antarctic, also losing a lot of mass. So it was losing 6 times more ice mass annually than it was 40 years ago, which is the sort of finding that we expected to happen when we first discovered what climate change was doing, like in the 70s and 80s.
Because if the temperature of the globe on average changes by 1 degree, the actual temperature fluctuations at the poles are a lot bigger. And so these 1 degree temperatures are unfortunate because it doesn't sound like such a big deal, but actually in more extreme environments, the swings are a lot bigger, which is causing a lot of these.
Yeah, and we had at least a sort of equilibrium on the Earth, and the extreme environments act as kind of a buffer zone. So we have all this ice that normally stays there year round, and it like absorbs some of the fluctuations. But if it continues to melt, then it won't be there to sort of shield us against climate change. And it's melting 6 times faster than it was 40 years ago. The other thing, which is where this gets even worse, is that not only are things melting, but they're melting at a rate that are faster than we expected them to be. So this report came out. UN panel signals a red alert on the blue planet. Basically, this came out that it was a revised projection of the sea level rise. We thought it was going to be, it's basically sea level rise we think will be 10 centimeters higher by the end of the century than we thought it would be, which is significant. Like that's this much of a difference, which since most people on the Earth, well, a lot of people live next to the sea, that's going to affect people directly. I think we're seeing a lot of these sorts of studies come through that are like, it's worse than we thought, because scientists are pretty inherently conservative in how they produce the results, right? To get through the process of peer review, it's easier to, papers survive more easily by not making super bold claims, right? And I think we're seeing a lot of those older studies be revised to be like, actually, it's worse than you were saying.
Yeah, 300 million people displaced would be the biggest refugee crisis.
And so this is triple what the previous estimate was. So and that's just in terms of flooding. That's in terms of people being displaced because of flooding, not because their place is too hot or because there's no water for them. That's just flooding. Speaking of water, a third of the Himalayan ice caps are doomed, which is a big deal because that is the water supply for about 2 billion people on the Earth. Most of our the densest populated parts of the planet is around the Himalayas. So that's a really big deal. Moving on a little bit from climate change specifically to the Earth problem more broadly, is that plastic pollution, which I've done a lot of videos on because it's a big deal, is not just affecting fish. Like there's millions of tons of plastic thrown out into the oceans every year, but it's not just affecting the fish life in there, it's also harming the bacteria that help us breathe. So it's harming the bacteria that make oxygen. And that's a big deal. That could have like a cascade impact that we don't really fully understand yet. That bacteria is responsible for 10% of the oxygen that we breathe, that humans breathe, and plastic is affecting it. So, that's the this is the last one. The conclusion is basically that this is the Anthropocene. This is a human-caused extinction event, and it's worse than we thought it was. What that means is that, I have it here, biodiversity loss is accelerating with over 1 million species now threatened with extinction. It's happening at an unprecedented rate. And Yeah, it's something that I think we all need to do a lot more about. Not just in terms of like your daily life. I mean, it's great if you can like reduce your impact personally, like drive less, fly less, buy less,
eat less red meat.
Yeah, that's all good, but we also, it's like way past time that we make some really big, significant government changes, and like we need to crack down on this big, like we need to stop taking fuel out of the ground, basically.
Is there anyone? So sometimes when I'm faced with all of this news, I start feeling a bit helpless, because you look at the amount of waste going on in large scale industry and in cities, and you're like, well, I can do my bit, but so is there any way that we as an individual can actually change, like leverage our votes from it, like on a political, like what's the best way that we can do things after, say, we've just set our own personal baseline to be?
So I think the two most important things you can, well, three most important things you can do are, first, you need to know about, I mean, this is like a 3-minute, 5-minute overview. You need to, like, everybody should be reading books and doing research, watching videos, like learning as much about the climate as they can. I think that once you do that, you're very empowered, because you realize that like your very existence is at threat. So once you've done that, you can vote, obviously, support climate, like climate people that are really hoping to make big changes in terms of what politicians have actual green policies that work. And also you can go and be an activist. You can protest. There's lots of things you can do. If you just like type in climate change activism in your city in Facebook, for example, you'll find places and people that you can join in. But we need to like really step up our game. That's it for climate change.
Okay.
Hopefully 2020 will be the big change year in terms of action, but let's cross our fingers.
Our live stream has hit 100 likes.
Well,
so that's some positive news.
Yeah. That is the only category, I think, that is really, really dark. So
yeah.
The rest of the year's summary should be pretty happy.
Okay.
Okay.
So we have still human evolution, artificial intelligence, technology, chemistry, and medicine. So please place your votes now. I will play some music. This is, okay, interesting information. This guitar, it's a lovely guitar, is a Larrivee guitar. We're not sponsored by them or anything. But this is the same make of guitar that's on the International Space Station. I don't remember if you, don't know if you remember seeing Chris Hadfield sing Space Oddity. Yeah, because he's Canadian.
Yeah, it's a Canadian guitar.
A Canadian guitar. They're actually made, we're both in Vancouver in Canada right now, and they actually make these guitars right here, and they're very lovely guitars. So you might have the same model of guitar that is on the International Space Station.
That's really cool. I'm seeing like a lot of votes for chemistry. I feel like it's a pretty clear win.
Okay, cool. Good, chemistry.
That's I am also excited to learn about chemistry, because that was Dom's topic.
Okay.
I'll get it up. Over. Da, 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 da.
Da, 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 da. I find chemistry fascinating because I only know tangentially what I know from what I've learned from physics. So I know kind of the fundamentals in terms of the periodic table and stuff like that. But some of this stuff in chemistry is amazing. So this is like a perfect way to follow the climate change news, because a lot of this is the kind of stuff that we can do which will help fight against climate change from a technological point of view. So groundbreaking new technique can turn plastic waste into energy dense fuels. So in terms of plastic pollution, there's so much of our plastic unfortunately ends up in the oceans. This is a new technique where you can actually take that plastic waste and turn it into a useful hydrocarbon fuel. It's still a hydrocarbon fuel, so it's still a fossil fuel, but it's at least a way of making something that's useful out of our plastic waste, which is very cool. I think this is the same one. Okay, yeah, science turned carbon dioxide back into coal. So this was a cool story because currently when we do carbon capture, we store it in liquids, and liquids are hard to store, and they take up a lot of volume, and they can leak into different places. Or gas. You can pump the carbon dioxide gas into the ground and store it underground, but there's always the potential that it leaks out. Storing it into coal as a solid is a much better solution for that, because it's going to stay there. Well, it's not completely inert probably, but it's going to stay for a lot longer and be a lot stable. And so if you put a load of coal back into the ground, that's going to be a much better way of storing it. To date, carbon has only been converted into a solid at very high temperatures, whereas this is a new technique that doesn't involve high temperatures. So creating high temperatures to convert the CO2 into coal obviously burns a lot of energy too, which is counterproductive. So this is a fantastic new way of doing carbon capture.
Yeah,
which is amazing.
It needs to be either very energy efficient or fueled by, well, it needs to be both energy efficient and fueled by renewable energy. Yeah. But like, that would be awesome if we could turn back the clock.
I'm just trying, because I remember reading this. I think this one you can do it through renewable energy sources.
Yeah, you should be able to.
Oh, this was using. Okay, yeah, I remember this. So this was using liquid metals as a catalyst. It's possible to turn the gas back into carbon at room temperature.
That's cool. And
it's efficient and scalable too. So, yeah, this could be great. Another one. It's hard to study chemical reactions directly because they happen so quickly that it's impossible to know exactly what's going on. But there's a new technique where you can actually image the actual chemical reactions.
That's cool.
Which is very cool.
That's interesting.
Yeah. So
radical desalination approach may disrupt the water industry. As water becomes more scarce, this is potentially good, right?
And this is specifically about hypersaline liquids. So that's when the amount of salt that's dissolved into the water is 6 to 10 times more than in normal seawater. And this happens a lot from industrial processes. And there's a list in the article of the processes that produce these hypersaline brines. And currently what you'd have to do is keep those isolated and separate from your water supply, because if they leak into the water supply, they can contaminate that. And also, to deal with them, currently the best way is to either do diffusion using a membrane. Is it called diffusion? I think it's diffusion, but it's basically having a gradient over a membrane, and those become harder and harder to do because you need a pressure on the membrane, and the more saturated the water is, the higher the salt content is, the harder it is to use a membrane to get rid of to get clean water out. And the other way to do it is actually to evaporate the water, to just leave the salt at the end, which is obviously energy intensive too, or it takes a very long time if you rely on sunlight. This is a different technique that doesn't need either of those. It's according to this, low cost and efficient.
Cool.
Temperature swing solvent extraction. So there's more information in that article. For those who've just joined, we're going to actually link to a couple of documents with all of this information, so you can go and see all the original articles at the end of the video. Okay, next one is energy researchers break the catalytic speed limit. This is, to me, sounds insane because they've made reactions occur up to 1,000 times faster than they would.
10,000.
10,000 times.
fold
Oh yeah,
increase.
10,000-fold increase in the speed of reactions when using a catalyst. So catalysts are basically, you have two chemicals you want to react with each other. They'll happen at a certain rate, but you can have a catalyst that actually helps the reaction out. It's like an intermediate step.
They're like cheerleaders. They don't play in the game, but they help the game.
Yeah. And so normally this is like you can have a solution of two chemicals that are going to react, and then you put in some metal into that solution, and that makes the reaction happen faster. But they've discovered that if you actually vibrate that piece of metal, so you like ultrasonic frequencies, you can increase the rate of those reactions by 10,000 times, which sounds like it would be incredibly useful.
That's cool.
In the article, it was saying the amount of different processes we use catalysts for is just a massive long list, and if you can increase the time,
make them all more efficient, make all sorts of drugs and all sorts of things more affordable. It'd be great.
Chemists make the first ever ring of pure carbon. So this is in the realm of carbon nanotubes and graphene. This is another type of carbon that they've managed to make, which is useful for making small-scale electronics in the future, hopefully.
That's cool.
Now, this is I think the coolest story. It's a way to make cement, but without causing any emissions. Now, this is a big deal because 8% of the carbon emissions on our world are because we're making cement to build buildings.
And roads and all sorts of things.
Yeah. And so this new technique is very cool because it eliminates the normal method that you would extract the bits of cement, which is normally used by heating up limestone. So when you heat up limestone, you need to burn fossil fuels to heat it up, and then also you need to the actual limestone, as it burns, it releases carbon too, and it's about 50% from each of those processes. This is a technique which uses electricity to create cement, and if you get the electricity from a renewable energy source, you can actually create cement without any source of greenhouse gases. The only emission is actually oxygen and hydrogen, which potentially you can combine to get energy out of it, and the only emission is water vapor. So this is very cool. It's not yet been scaled up, so scaling it up for global cement production is going to take time, and it's not a thing currently that you can just roll out. So they're saying that the best way to do this is it's a multi-step process, and so maybe you can replace one part of the cement production with one part of this, and then do it as a staggered approach. But anyway.
But this is like a really big deal because, I mean, we have all sorts of renewable energy options. We're starting to figure out transportation like electric cars and even electric planes, but cement has been like the big, like, we don't know what we're going to do. Like, what are we going to use for roads? This is cool.
Very cool. So if that's the end of the chemistry section, but if advances like this keep on happening, we can attack climate change from the technological point of view. We can't. I think it's dangerous to rely on that, because that's what a lot of very optimistic technologists say, is that we can just innovate our way out of this catastrophe. I don't think 100% we shouldn't be relying on that. We need to do the political movements too, but
now we have options, which is an important step. Cool. Okay, so next category we're looking at,
we have human evolution, technology, and medicine. Oh, I missed artificial intelligence.
Human evolution is like all of biology, but it's mostly human evolution.
Yeah, that's true.
Yeah. Love this live stream. Thank you. We got a couple for Evo. I think it's all Evo and oxygenation, which isn't a category. I don't know why. I missed something in the thread. That's why I'm talking about that. And someone's voting nothing. Very helpful. I think, and I'm seeing AI. Overall, I see more for human evolution.
Okay, let's do it.
Which I'm happy to do. Okay. Okay, bring this up so I have my notes. Okay, right at the start. This is so a lot of these studies didn't actually even make. Oh, this is the wrong one. It needs to be this one first.
Okay.
A lot of these studies didn't make big news, but they're really fascinating. They might have obscure titles, so that's a warning for this section. Japanese team edges closer to bringing mammoths back to life. So there's a bunch of research being done to de-extinct animals like the passenger pigeon, because we have all of their DNA and we have similar animals that we could use to birth those creatures. So basically the idea for this is that they would take mammoth DNA, which we find from like old mammoth tusks, which is cool. And we can use that DNA and put it into an embryo and put that into an elephant and create a woolly mammoth for the first time in like 10,000, 28,000 years. They've been extinct for a very, very long time. So this is neat. There's all sorts of questions about like, should we be doing this? What would be the point? But like either way, it's interesting science. Yeah. Next up.
Not sure how I feel about making the ethical side of things. A woolly mammoth, I mean, it would be cool, but what would we do with it? We would just have it in a zoo and make money from it.
We might, yeah. I think this isn't. It gets really tricky to answer that sort of question when you think about like, why did woolly mammoths go extinct in the first place? It was probably largely from humans. Like we hunted them, and that's going to be the case for like the passenger pigeon. We caused that to go extinct. We killed them. So like maybe for some of those things, like it would be good to like take it back. Whoops,
I could see a use case in environments when we've ruined like a keystone species of an environment and now it's extinct. Reintroducing that makes a lot of sense.
Yeah.
The woolly mammoth, it's been extinct for such a long time, I'm not sure. But anyway, not to derail things.
So this is a complicated title, but what's really cool about this study is that researchers basically looked at the DNA of humans and figured out that there was code there from something else that was probably another type of human. So like there was probably based on this like kind of genetic modeling, they figured out that there's an extinct species of human, not Homo sapien, but a relative, just from DNA within us. We found that existed at one point. That's really cool.
Very cool. Yeah.
So like we don't have fossils of them, but we know that they existed.
So it's not a Neanderthal. It's not a what are they?
Humanist hybrid.
Yeah.
It's something completely different, which is really cool. Also, we know that because just like Neanderthal, we bred with them. Like our great ancestors were making babies with them, and some of their DNA lingered in us, which is neat. It's kind of like, to give an analogy, it's like searching for Planet 9. We've not seen Planet 9, but we can figure out that it probably exists because of the way that gravity pulls things in the orbits of planets.
Very cool.
We can see it in DNA. That's really neat. I think that's like the first time that's happened with humans. Okay, so going further back to Neanderthal, our ancient relatives. What was this paper about? Oh yeah, we found out a bunch of things about Neanderthal. So we looked at the isotopes of carbon and nitrogen, which basically allow us to gauge what was happening at the time those individuals were alive. Based on complicated chemistry, we figured out that they probably ate meat, which is something that we didn't know for sure, because meat doesn't really keep in terms of, it doesn't really fossilize very well. And they also probably walked upright, much like modern humans. So we learned a lot about Neanderthal, which is kind of neat. We've discovered fossils of a very large bird. It is, what is it called? A giant parrot named the Hercules parrot, which is pretty cool. It was almost a meter tall. It was 1 meter tall, which is a giant bird.
That's cool.
Kind of neat. They also discovered the fossil remnants of, what is it called? A fossilized fungus. So this is going further and further back, way before humans. Some of the earliest things to go on land as life were probably fungus that paved the way for plants. And fungi don't fossilize very well, so it's very, very rare for us to see fossils of them. But this is really neat. This is a billion-year-old fossil of a mushroom, essentially, which is really neat. And then, hold on, I gotta bring that up. They also, going way back to basically the beginning of complex life, they've discovered this very large Medusa virus, or a relative of it, that was probably responsible for the very first complicated your eukaryotic cells. So basically, what they think happened is simple prokaryotic cells. How to begin this? Like bacteria combined to make these eukaryotic cells that we have, that plants have, that fungi have. So that's really, really, really neat. They're basically discovering the very start of life with this project. It was a giant virus.
That's interesting.
Yeah. And that is like all of.
Yeah, I thought you branched out into.
Yeah, everything. From the start to
that's
the very beginning of it. That's that category.
Next category. So we've got artificial intelligence, technology, and medicine left. So I
need to bring up the live stream.
Yeah, earlier I saw a lot of votes for artificial intelligence.
I was seeing a lot of votes for AI.
So let's see.
Some fungi, microbials. Yeah, I don't think they taste good anymore. They'd be rock now. Any votes? I mean, we could rely on the earlier vote. Yeah, AI. Lots of AI votes.
Lots of AI. Okay, cool.
Okay, I'll bring up my notes.
So, in the world of AI,
artificial intelligence,
in 2019,
it was a big year for AI.
Yes, I mean since 2010, pretty much every single year is a big year for AI because it's expanding and getting more and more elaborate every single year. We're really in a sort of golden age of AI currently. So a lot of these news stories revolve around AI playing games. So this one is DeepMind, Google's or Alphabet's company. They learned how to play StarCraft 2 so well that they beat professional players, I think, in 10 out of 11 games.
Which is, as someone who's like tried to play StarCraft, it's hard. And then watching people play it online, like the professionals, it's like I don't even know the human body can click that fast.
Yeah.
And it's hard.
And this is a big step up from beating like Atari games and stuff like that, because you're playing against a human opponent, and you're also playing with imperfect knowledge, because a lot of the other games you have all the perfect knowledge of what the game's doing, but because a lot of I've never actually played StarCraft, but from what I understand is there's hidden areas of the map to begin with. It's all hidden, and you have to send scouts out to get information to know what your opponents are doing and where they're doing those. And so this is, in terms of games, this is a very complicated game. Step up from Go and chess and the other things that they do. So this is
very cool.
A cool thing. You've already covered this. This is finding a ghost ancestor in the human genome. So yeah, we've covered this already.
Yeah, some of these topics use multiple fields of science, right? When we talk about like this is just chemistry. It's like, well, I mean, science is very collaborative.
Yeah. So this is cool, using AI on genetics to actually discover creatures in our genome. Like, I think it's fascinating. Just to tie a few threads together. Early on, we were talking about how DNA is a data storage device.
Yeah.
And this is now doing information science and machine learning on that information source. If we had some kind of like ultimate knowledge of how DNA ends up encoding creatures, it would be an insanely powerful thing to do, because we could retrace all of evolutionary history just by looking at the DNA of the animals that exist now and see basically all of the intermediary animals that probably existed.
And that's like kind of the goal.
I guess it is to just fundamentally understand how DNA turns into creatures.
What's super wild is that it was in the 60s that we even discovered DNA, like 60 years ago. And now we're like, oh, this species existed because of how well we can read and understand DNA. That's incredible. Cool.
Brilliant. Okay, this is another games. So this is Carnegie Mellon University beating top professional Texas Hold'em poker players, people who've won millions of dollars playing poker.
Again, you're working with imperfect information.
Imperfect information, and also playing against 6 opponents at a time, which is more difficult than just doing one opponent. And so again, heads up play.
And again, broadly, like you're like, oh, why do I care that AI can play games? Well, it's like if it can solve these sorts of problems, we can also use it to solve important problems. But this is like a really easy way to test that out.
Games are a nice test case for AI because they have solid rules. So the world in which they solve the problem is constrained. So when you're trying to build something like a self-driving car, you're dealing with the actual real world, and the complexity of the real world is basically endless. Whereas with games, you know that there's a certain limit to the rules that you're trying to beat. So that's why a lot of these early results are in specifically games, because that's something that we can encode better for a computer. In fact, one of the things that we find fascinating as humans about games is because they're complicated systems that we're not actually very good at solving. So computers in a way are more they can do more stuff when it comes to enumerating all the different possibilities of poker hands. They can just know all of the probabilities off the top of their head, which is already an advantage. If you could do that as a human, that would give you an advantage. The other thing that's really interesting about these things, when AlphaGo beat the best Go player in the world, it did things that Go players were really surprised at. And so it had actually created new strategies that no human had ever thought of. And the same thing happened in poker. They were surprised at some of the decisions that this AI chose to do to beat the humans. Also, another thing about playing poker is that you want to not be predictable. And so you want to have a certain amount of randomness to the strategies that you play. And it's easier for a computer to do that.
The ultimate poker face. No face.
That's also true.
Cool.
So that's cool. An Atari game. So this is RMIT University have performed. They've completed Montezuma's Revenge 10 times faster than Google did.
Which is apparently a very difficult game.
Yeah. We have a robotic hand can solve a Rubik's Cube. So this is not only... well, I guess solving Rubik's Cubes is fairly easy from a computational point of view, but the manipulation of an object like a Rubik's Cube in a hand is really hard. So
in
robotics,
a human-styled hand.
Human-styled
really
hand,
neat.
yeah. So this is machine learning as it applies to medicine. So using image recognition, AI can detect 26 skin conditions as accurately as dermatologists can.
That's so cool.
Which is very cool. If we can automate things like detection of skin conditions, that would be huge.
Yeah, I mean, we already I go straight to Google. I've been sick the last few days, and I go straight to Google to be like, what is this? It would be so cool if I could what are my tonsils doing? I take a photo and Google tells me. That's neat.
Yeah, so this is, I think, in general, a really, really interesting area is applying machine learning to medicine, and then actually testing it against, the key thing is to test it against the experts and see how well these machines do. So, okay, so this is...
They've identified... AI-based drug discovery platform has identified a target and drug candidate for Wilson's disease.
So this is basically trying to look through how drugs interact with the body, and you can apply machine learning to drug discovery as well. And so this is a result in that.
Very cool.
Yeah. Okay.
All right.
So, this is not supposed to be here. This is something about decoherence in quantum measurements.
We've already done physics, so that's fine. Okay, cool.
Okay.
There's
we are
two
down
categories
to
left.
the final two categories. We've done. I forgot to scrub off artificial intelligence.
Yeah, we can do that. So it's now between medicine and technology. Cast your votes in the comment section, please. And there's going to be, obviously, again, overlap between these last two, because we've talked about a lot of the medicine and genetic and engineering things, but
technology crosses over quite a lot with AI and physics as well, which I found. So
1 vote for tech, 2 votes for tech, 3 votes for. Okay, we're going with tech. Sorry,
okay, technology.
Sorry,
and then medicine.
Pick maniac. We'll get to your medicine next.
Okay.
Cool. All right. Yeah, you do it.
I'll go back.
We've got 3 computers, so I'm grabbing the wrong mice to make this happen. Nope.
No, space. That was space physics.
Tech, right? It's doing this way.
Oh yeah, sorry. That's how letters work.
Cool.
Okay, so lots of 3D printing results. So I'll just rapid fire some of these. So technology. I've got a list.
As the title says, 3D printing the human heart. That could be cool. Okay.
So yeah, 3D printing organs is good. So research at the University of Michigan demonstrates a new approach to 3D printing based on lifting shapes from a vat of liquid. So it's a new way of extruding objects out of a liquid. It's 100 times faster than previous processes. So speed ups in 3D printing. There's this story which is 3D printing, bioprinting tissue scaffolds made from collagen. So this is cool for potentially building replacement organs using your own stem cells, using your own cells, so they won't get rejected by your body. And also you don't have to do the crazy
pig
making,
thing.
doing the pig thing, which is good if you can avoid,
Yeah.
There's also a new type of 3D printing that can print an object the size of a human in 2 hours.
That's wild.
So you can print much bigger objects than you used to be able to. My
friend Jesse has a 3D printer, and it's really fascinating. But God, it's slow.
So slow. Yeah. It's okay, I'll do 2 days later. I'll come back.
Yeah.
There's also at the Rensselaer Polytechnic Institute, they just demonstrated a way to 3D print living skin, including blood vessels.
Wow.
Which could be used for more accurate skin grafts, which just sounds wild, which is very, very cool. So lots of advances in 3D printing. That's the blood vessels.
Images.
In technology, the first 1 terabyte SD card was built.
As someone that uses a lot of SD cards to make videos, I'm excited about that. I'm not gonna lie.
That is an insane amount of data.
Yeah.
This is very cool. So there's a passive way of cooling buildings, which is this box here, which basically doesn't need any electricity or batteries or anything, and it can cool certain areas of a building down by 11 degrees Celsius. I think just fairly small areas. But what it does is it beams the energy into space, which is the cool thing. So what it does is,
we can't make this up, I tell you.
It absorbs heat from the air around it. So the air in this cavity, the energy from that is transferred into these veins, and then the veins emit the infrared radiation into space at a wavelength where it doesn't then get reabsorbed by the atmosphere as that travels out.
That is so cool.
So yeah, passive cooling is amazing. Air conditioning systems in hot areas use a lot of energy.
This is great because the planet's getting warmer, And people are currently like using more air conditioning to keep their houses cooler, and they're using more fuel. So this is awesome. Plus, like that blows my mind. Space. That's cool. That's neat.
Very cool.
More 3D printing.
With 3D printing at the nanoscale, so 1,000 times faster printing at the nanoscale, which is very cool. Oh yeah, this is Google's results of quantum supremacy. You probably heard this earlier in the year. For those of you who haven't heard this, so quantum computers are computers that use the laws of quantum mechanics to solve problems. So that's basically very small things that use superposition and entanglement. It allows you to compute in a different way to normal computers. So they can solve certain problems a lot faster, or they've got the potential to solve certain problems a lot faster than the binary classical computers we use. So a bunch of companies around the world are in a race to make quantum computers that are at scale where you can actually solve real world problems. They're not there yet, but this is one benchmark on the way there, which is this so-called quantum supremacy. I've done some videos on my channel about quantum computing and one on quantum supremacy specifically. And what this is basically demonstrating that this quantum computer can solve one problem faster than any classical computer can, faster than the most powerful supercomputer. And so Google demonstrated this on a problem which is not a useful problem, so it's not actually solving a useful problem, but just being able to solve any kind of problem faster than a classical computer is a good result. The results got disputed by IBM, who have the world's fastest supercomputer. So their reasoning made sense, and I don't think they've published yet, but they're going to publish a paper which is a challenge to this paper. And honestly, I'm not surprised. The war between quantum computing and classical computing is going to be this stepwise race where one shows a result in quantum computing, and then they'll innovate in terms of classical computing to come up with some clever technique. Classical computers are so insanely adaptable. You can engineer them to do all sorts of things. And I kind of, in my old job when I was working with quantum computing, I kind of experienced some of this exact stuff firsthand. But anyway, it's a very cool result. And the advances in quantum computing are fascinating. The potential for quantum computing for specifically simulating quantum systems, I think is really exciting. So this is in terms of chemistry, drug discovery, finding new materials. Currently, our computers are not powerful enough to simulate lots of atoms all interacting with each other. Even in the biggest supercomputers, we can only simulate small systems of atoms. In the future, if we have large-scale quantum computers, they're literally a simulation of atoms interacting with each other. And so if we can run simulations at a large scale, that will be a huge technology. It's like a computing the fundamental of materials. Engineers develop a new way to remove carbon dioxide from the air. So this I put in the technology instead of the chemistry area. The reason this is cool is because it can remove carbon dioxide from the air any concentration level. Traditional techniques want a high concentration of carbon to be the most efficient.
And it uses, is this the one that uses batteries? Involves batteries? No?
Yes. So this is basically, it uses the carbon in the air to charge up a battery. So it's like the thing that charges up the battery. Instead of electrons, it's actually carbon.
And then you have carbon sequestered from the air, which is good.
And
so
then
it's like a double whammy.
Yeah,
it's
double whammy.
Punch.
And if you want, you can release the carbon again to release the electricity, and then maybe capture the carbon in some other way. I don't know.
That's cool.
So that's very cool. More efficient solar cells through nanotechnology, so converting infrared light into energy more efficiently than before. There's a number to this. 10%. So increasing the efficiency to 10%, and perhaps up to 20 to 25% more efficient solar cells. And it makes, you can see this array of lenses that actually focus the light, which is how that works.
This next one's wild.
Self.
Sorry.
Yeah. So
I'm just excited.
Google have built a factory to build self-driving cars in Michigan, which I didn't know. But
it's finally happening.
Yeah, cranking out self-driving cars. I'm a bit of a self-driving car skeptic. Yeah, because I feel like the problem they're trying to solve is so difficult that the things we're talking about, I think in mainstream consciousness and how the news has talked about self-driving cars, I'm a little bit surprised that people think it's so close. Right. I don't think it's as close as what people are claiming. So this, I mean, a lot of people are saying within the next 2, 3, 4, 5 years or something like that, but I think it's going to be further off than that for the very reasons I was stating earlier. Like the world is incredibly complicated, and these self-driving cars, if you want to be able to sit back and just not be attentive at the steering wheel, it just completely controls itself. I just don't see that it's there yet.
So the harder parts for self-driving cars seem to be like in inner city short distance travel, right?
Yeah.
Because there's like a lot of information for it to take in, and there's a lot of people and pedestrians and so on. But the like most deadly accidents for drivers and passengers are on the highway, which like self-driving technology has gotten pretty good at that.
Yeah, so highway driving is the easiest,
which is great
it's the most
because you're traveling at like hundreds of kilometers an hour.
Yeah. So that's true.
I'm excited.
Yeah, okay, that's good. I mean, I'm excited too, but I'm just trying to be realistic.
Yeah,
fair.
I
don't want to.
That's fair.
I would absolutely love there to be self-driving cars today. Yes.
Coming. It's still
coming.
News.
And then this one is slightly silly, but also very cool. The world's largest computer chip, which is like this big or something. So your CPU is normally about an inch in the middle of your computer. Now you could have a CPU that's a massive slab.
Is that good? Do we want them bigger? I guess there's like more.
I guess you've just got more computing power in that one chip. I think the problem would be that it would heat up so much.
Yeah.
Because that's, I think, one of the limits. Anyway.
Cool.
Technology.
We're not even going to let you vote on the next category.
No.
Because there's only one left. Actually, let's let you vote. Anyone?
Anyone
want to vote for medicine?
Or the secret wild card, which is me rambling about aliens.
Well,
again.
we do actually have a secret wild card.
Oh yeah, we do. We do have a secret.
But we're not. We're gonna do medicine.
Okay.
Okay. Medicine's mine. Yes. I should do the things. Okay, go back. Where is? There we go. Big year for medicine. Again, some overlap with DNA. Executive file. There we go. Okay. Some overlap with genetics because now we're using that in medicine, which is neat. So there was a big, really cool case of an unfortunate circumstance turned good. This teenager had a lung transplant, was it? Let's see. I think it was a lung transplant. Got to go up to the top of my notes.
Getting lots of votes for medicine.
Yeah,
that's good.
That's good. So this teenager had a lung transplant, which to begin with is amazing. But then they had a deadly infection. Not good. And then we had a thing called genetically modified phage therapy, which a phage is like a virus that looks like the virus. It looks, if you've seen The Matrix and that thing that goes into Neo's belly button, phage viruses look like that. But we were able to use them to create it's like a drug resistant technology. All of our drugs, all of bacteria and the viruses that we use drugs on are getting resistant to those drugs. We might have a completely new way of affecting those. So that's awesome. She's 17 and seems to be doing well, which is cool.
That's very cool.
End to AIDS. So this is a really cool large study of 1,000 gay male couples who took this antiretroviral therapy. And this is like a big study that's been happening over the last 8 years. And with this antiretroviral therapy is basically a number of like a concoction of different things that are bad for the virus. And when you take all of these in concert, what they found is that the virus does not transfer from one partner to the other, which is awesome because if we use this like effectively, we could eradicate AIDS.
Yeah, that's cool.
Which is like really exciting. That's huge news. So that's cool. They found that there were no further infections, which is like the best news possible. This is all the articles about this were like really weird because they were like dinosaur metal. It was like it was the metal from an asteroid.
I want to listen to dinosaur metal. I think that sounds like good music.
Yeah. Some of these things, it's like, well, how do we talk about them? But there's this obscure metal that they can. So it's iridium attached to albumin, which I'm not sure if I can pronounce. But anyway, they basically put it into cancer cells, and then they can shine light on it. And that irradiation can destroy those cancer cells. What's cool is that they can basically give people this metal as a drug. It will go into the cancer cells. It will get uptaken by them, and then they just shine light on it, and it kills them because the metals heat up, I think. It's from photodynamic therapy. I don't know exactly what that means, but
very cool.
Really, really neat process for. So this section is like the aging and cancer section. Gene therapy reverses congenital deafness in mice. Okay, right. So this article, a lot of the studies in medicine are done in medicine, done in mice, but maybe applicable for humans. We don't really have that many ways of restoring like hearing at all, but this is genetically deaf mice, but they've been able to basically turn that gene back on and allow them to hear again, which is really, really neat. Hopefully that will be available in humans at some point. Another gene therapy example, this woman was the first person to have the aging blindness halted.
That's very cool.
Really, really neat. So it's age-related macular degeneration. What they did is they injected a virus into her retinal cells, and that virus held the DNA that was injected through the virus into her cells that basically stopped them from producing the stuff that was causing her blindness. So
yeah, amazing.
That's amazing. It didn't like reverse, as far as I could tell. It didn't reverse her blindness, but it stopped it from progressing. So in theory, when
if you catch it early enough,
you could prevent it entirely, which is really, really neat. This study to me was like really fascinating and super exciting. Alzheimer's is where you have like really extreme memory loss, and it affects, I think I maybe wrote it down, it affects like millions of people, a huge percentage of the population. And as you get older, it's a high probability disease. They basically, researchers gave participants this headset that put electromagnetic waves that affected, basically it's kind of like a plaque that develops on your neurons, and it basically like vibrates them and destroys them. And it was able to reverse the effects of Alzheimer's in the people that used this just for 2 times a day for an hour. Like really simple. You can just like wear it and walk around normally. But it reversed the effects of Alzheimer's for what, like the equivalent of a year of degeneration. So it was like they got their life back to a year where they were earlier.
Just sounds almost too good to be true. That's
really, really neat. So
no drugs or anything, just put on this headset.
Yeah, the interview from the researcher that did this was so like heartwarming. He was like, we get like data and it shows that these things are working. But the thing that really drove it home to me is that out of all the participants we gave the headset to, none of them wanted to give it back at the end of the experiment. And someone even said, a patient said, "I've come back," which is like, wow, like that's just fascinating and so exciting. Anyway.
Very cool.
So there's hope for hope for that. Again, this is a topic that
Yeah,
you
yeah,
covered,
yeah.
but huge advancements in medicine through 3D printing. Oh yeah, this is also really like this is future medicine. Nanotechnology made it possible for mice to see in infrared, which is like what? Okay, so what they've basically done is put in this, what was it called, a nanoparticle, some sort of, I think it was maybe even a metal, but what it did, I could be wrong in that, but what it did was it refracted the light. They injected this little thing into these mice's eyes, and it bent the wavelengths of light so that infrared, which is a large wavelength, I think, right, Don?
Sorry, infrared is a longer wavelength.
Yeah, it's a longer wavelength than visible light, and it basically bent it to be a shorter wavelength so that the mice could see it.
That's cool.
So that's really neat, and the effect lasted up to 10 weeks, which is really cool. Would be really wild if we could like have like temporary see different wavelengths of light. That'd be neat.
To add to the increased brain capacity from the 8 base DNA.
Yeah, exactly. Cool. That's it for medicine.
It for
There were a
medicine.
lot of other in mice studies that we'll see where those go in the next few years, but very exciting.
And that's it. We've got to the end of our list. We've checked them all off. Thanks everyone for being on the stream. We'd just like to finish with our pick of the best stories of the decade. As we're getting to the end of the, what do we call them? I've gone through this whole decade without actually knowing what to call them.
2010s.
The 2010s?
Yeah.
The tweens?
The 2010s.
Okay.
Yeah, there's a lot of things that happened. I was just blown away this morning thinking about this. The Curiosity rover landed in 2012. That was this decade.
Yes, yeah.
I thought that was longer ago. There's a lot that's happened.
So in the stream, how about you give us what you think your best, what the best science stories of the last decade are? Shout out, and we'll try and do a list at the end. We'll just do a few of our picks. So Curiosity rover was one massive one. Another one was the detection of gravitational waves for the very first time.
Yeah,
that is 2016.
Recently.
Yeah, 2015 was when it was done, but it was published in 2016. But that's amazing. A whole new mechanism that we can look into space, and so that's going to be. It's already been astounding what we've discovered.
Yeah. We found thousands of exoplanets, planets not in our solar system but elsewhere. Like
the Kepler space probe.
This is the one where literally more of them come out every day. So I don't know what the current count is, but last time I checked, there was like 4,500 planets, including Kepler 22b, which looks to be pretty similar to Earth, which is cool. Yeah.
Discovered the Higgs boson.
Oh yeah.
So that happened this decade, which is amazing.
The God particle.
The God, right? Well, yeah, I don't like that.
That's why I use the bunny ears for those.
But yeah, that completes the standard model of particle physics. We found the Higgs boson, which is amazing.
Came up with CRISPR-Cas9, which is like already, as you saw, medicine and genetics. Like that's a new technology as of this decade, and we're already using it to solve all sorts of human ailments, which is pretty neat.
Levi says Higgs particle, good one.
Yeah.
Black hole discovery was the favorite. Higgs boson, couple for Higgs boson. Quantum computing, LIGO, graphene. Yeah, graphene. A lot of stuff's been happening in graphene, which is cool. Quantum computing is cool. So that's been going on since, the 90s, actually. But in the last decade, it's actually hit its stride. And now, for the first time, at-scale quantum computers are being made.
Found water in the solar system, not just on Mars, which we talked about from 2019, but also we found it on the moon and in Europa. Europa one, I think, well, Mars and Europa is really cool. They with Mars, they saw an asteroid hit Mars and looked at the plume and saw basically steam rising, which is really, really neat. Mm-hmm. One thing I was really excited about from this decade, because I love the environment, but I also really love space and space travel, and those two things often kind of compete. We came up with reusable rockets. Like SpaceX and a couple other companies launched rockets that could land. That's mind-blowing. That's so cool.
Yeah, we've got age reversal on the feed.
Yeah, in mice.
Is that true? Oh, in mice. Okay.
Yeah. So we've come along, and like there's a lot of studies that's
I
like,
was not aware of that. That's
well,
interesting.
there's a number of studies, so it's hard to like really define when that happened, but there's been a lot of progress in that. So we'll see what happens for humans in the next decade.
What was the AI in general? Yeah, that's
Yeah.
another one. AI has come up such a long way. This AI boom kind of started around 2008, 2009.
Yeah.
And so, yeah, it's been the decade of AI, basically, which is very cool.
Voyager left the solar system several times. I mean that in that like we kept Voyager, the space probe that we launched in 1977, as it like passed all of the planets and then passed the dwarf planets and then the Oort cloud. We just kept thinking like, oh, that's the end of the solar system, but it just kept going and finding more stuff. But at some point, it definitely left the solar system, which is cool.
Carty says Umau Mau left the chat.
Yeah.
That's good. Yeah, that was a cool discovery.
Like, popped this like weird space item popped in and out of our solar system really, really quickly and weirdly.
Axel Soderberg says new state of matter in space.
I don't know.
I didn't know about that. Would you care to elaborate, Axel?
Oh yeah, the world's first malaria vaccine program began this year.
That's cool.
But like that vaccine has been developed over the last decade. Really, really cool.
Bitcoin? Someone says Bitcoin. I think that started in 2007, but it's exploded over this decade. I kind of wish I had bought some in 2007.
I tried to.
No way.
It's a long story, but I would have had a lot of money from that. But it's okay. Anyway, a new Tool album.
New Tool album. Yeah.
Big science discovery. I mean, that's like a decade in a couple minutes, I guess. But it's been really cool and it's been super exciting. And I'm looking forward to seeing what happens in the next 10 years.
Yeah. So thanks for joining us on this long live stream. It's been over 2 hours now.
That's so awesome.
So we probably need to shut up and go away. But thanks for sticking with us. I hope you've enjoyed that. I guess this is the time where we plug things. So Curtis, please, you got anything you'd like to plug?
I have two things. One, if you want to go check out the videos that I make over on my channel, it is just Curtis Bowdy. If you search Guy Seals Himself in a Jar, you'll probably find it. The other thing is and maybe I'm stealing this from you, we used Wikipedia to find like all of this. Like that's where all of this started. So, and Wikipedia is run from donations. So if you want to help support Wikipedia, make things like this possible, go and donate to Wikipedia. Just go to Wikipedia and click the donate button. Yeah,
I would just want to reiterate that Wikipedia, I think, is something that a lot of us take for granted that it exists, but it wouldn't need to exist. It was just the fact that when Jimmy Wales started, he decided, I'm not going to try and monetize this through advertising. And we know from Google and we know from Facebook and all the rest of social media how creepy targeted ad, and even YouTube too, which we're on here, so slightly hypocritical. But all of this stuff, the machine learning about targeted advertising is really, really creepy. So donating to Wikipedia, that's how they rely on keeping it free for anyone to use and anyone into the world. I believe very strongly about access to education, which is my motivation for doing YouTube, because I want to create educational resources that can be freely accessed, and Wikipedia is like the most amazing version of that. So I would really encourage everyone here, if you've got a bit of spare cash, to go to Wikipedia and donate to them, whatever you can afford. I put a really messy link in the chat, but we'll leave another one in the description. Yeah, we'll put one in the description too. So if you're watching this at a later date, go do that. And as for plugging my stuff, I mean, check out my channel, do all the normal stuff we always say, like and subscribe and all that. I also sell merchandise. So this is a lovely quantum mechanics inspired mug. I also sell lots of posters on DFTBA, so just search Domain of Science on DFTBA to find stuff. We also both have Patreons too. Anyway. This has been a lot of fun. I hope you enjoyed it. Thank you. Yeah, thank you. Okay. Shall I play us out? Sure. Well, you find I will find the stop button. I think it's this button. That's it for 2000. I don't want to end it.